algebra of matrices, I take four numbers 1, 2, 3, 4. These four numbers can be arranged in different ways. First, numbers arranged in a row. Second, number arranged in a column. Third, first two number arranged in first row and second two number arranged in second row. This type of arrangement is rectangular arrangement, or all three represent the matrices. So matrix is rectangular arrangement of numbers. These numbers may be real or complex, letters or characters in row or column, under the condition that each row and each column has same number of elements. I repeat again, rectangular arrangement of numbers in row and column under the condition that each row and each column has same number of elements. I take some examples. Is this representation represent a matrix? Yes, it is represent a matrix, because in this representation there are two row and two columns. First row has two element, second row has two element, or first column has two element, second column has two element, so it is matrix. Is this matrix? No, because first column has two element but second column has one element, so it is not a matrix. Is this representation is a matrix? No, because the first column has two element, third column has two element, but second column has one element, so it is not a matrix. A matrix is denoted by capital letter. A, B, C, etc. I take an example, matrix A. 1, 2, 3, 4, 5, 6. This is the first horizontal line, is first row. Second row. This is the third row, R3. This is the first column, C1, second column, C2. The first horizontal line is called first row, second horizontal line is called second row, third horizontal line is called third row, first vertical line is first column, second vertical line is second column. A matrix has three basic things. First, elements or component or entry. 1, 2, 3, 4, 5, 6. This matrix has 6 elements. 1, 2, 3, 4, 5, 6 are called element of this matrix, component of this matrix, and entry of this matrix. The second is second order. In this matrix, number of row 3, number of column 2. So order of matrix is equal to number of row into number of column, 2 into 3 into 2. The order of this matrix is 3 into 2. If a matrix has m row and n column, then order of matrix is m by n. If a matrix has m row and n column, then order of matrix is equal to m into n. Third is position of element. Position of elements. Position of elements, A, I, J. I represent row, J represent column. Aij means element lies in ith row and jth column. In this example, position of 1, position of element 1 lies in first row and first column, so its position is A11. Position of element 2 lies in first row and second column, so its position is A12, first row, second column. Position of element 3 in this matrix, 3 lies in second row and first column, so its position is A21. Position of element 4 lies in second row and second column, so position of element 4 is A22. 5 position of element 5 lies in third row and first column, so its position is A31. Position of element 6 lies in third row and third column, second column, third row and second column, so its position is A32. Type of matrices. First, if a matrix has exactly one row, so matrix is called row matrix or row vector. This matrix has one row and 3 columns, so its order is 1 into 3, number of row into number of column. Second, if a matrix has exactly one column, the matrix is called column matrix or column vector. What is order of this matrix? This matrix has first row, second row, third row. This matrix has 3 row and 1 column, so its order is 3 into 1. Number 3, if a matrix has equal number of row and column, is called square matrix. Number of row is equal to number of column. M is equal to n. Then the matrix is square matrix. Number 4, if a matrix has unequal row and column, rectangular matrix. In this matrix, number of row 2, number of column 3, so number of row not equal to number of column, m not equal to n. This matrix is called rectangular matrix. Number 5, diagonal matrix. Before diagonal matrix, I take extended matrix A11, A12, A13, A21, A22, A23, A31, A32, A33. These elements are called diagonal elements. A11, A22, A33. Diagonal elements. A12, A13, A21, etc. are non-diagonal elements. Non-diagonal elements. Diagonal matrix, it is a square matrix. Diagonal matrix, it is a square matrix in which all non-diagonal elements are 0. Square matrix means number of row is equal to number of column. This is the diagonal matrix. It is a square matrix and all non-diagonal elements, these are the diagonal elements and non-diagonal elements are 0, so it is diagonal matrix. Another example, 3 0 0 0 5 0 0 0 1. Diagonal elements are 3 5 1 and non-diagonal elements are 0, so it is diagonal matrix. This diagonal matrix can be written as diagonal 3 5 1. This is the diagonal matrix. So diagonal matrix is a square matrix in which all non-diagonal elements are 0. Number 6, scalar matrix. It is a diagonal matrix in which all diagonal elements are equal. It is a diagonal matrix in which all diagonal elements are equal. Diagonal matrix means it must be a square matrix and its non-diagonal elements are 0. A matrix A is equal to 2 0 0 0 2 0 0 0 2. It is a scalar matrix. His all diagonal elements are equal. That is Aij is equal to K if I is equal to J for diagonal elements, 0 if I not equal to J for non-diagonal elements. Number 7, unit or identity matrix. It is also a diagonal matrix in which all diagonal elements are unit, means 1. It is denoted by I 1 0 0 1. All diagonal elements are 1, so it is identity matrix of order 2 by 2. It is also written as I2. 1 0 0 0 1 0 0 0 1. All diagonal elements are equal, so it is identity matrix of order 3 by 3. It is also written as I3. That is Aij is equal to 1 if I is equal to J for diagonal elements, 0 if I not equal to J for non-diagonal elements. Zero matrix or null matrix. A matrix is zero matrix if whose all elements are 0 is called zero matrix. It may be square or rectangular. Zero matrix may be square or rectangular. Equality of matrices. Two matrices A and B are equal if they are of same order. Second is element in the corresponding position of two matrices are equal. दो मैट्रिक्स इक्वल होंगे यदि उनका ऑर्डर सेम हो और करस्पॉन्डिंग पोजीशंस पर एलिमेंट भी सेम हो तो दोनों मैट्रिक्स इक्वल मैट्रिक्स होंगे. फॉर एग्जांपल, मैट्रिक्स is equal to the matrix. Both matrices are equal, so element on their corresponding position is also equal. In this matrix, the 1 1 position is 3. In this matrix, the 1 1 position is A, so A is equal to 3 for equal matrix. In this matrix, 1 3 position is 8. In this matrix, 1 3 position is B, so B is equal to 8. In this matrix, 2 3 position is 0, and in this matrix 2 3 position is C, so C is equal to 0. For equal matrix, elements on corresponding positions are equal and they have same order. The next is comparable matrix. Two matrices are comparable if they have same order. Two matrices are comparable if they have same order. We take an example. Matrix A is equal to matrix B is equal to. Matrix A is of order 2 by 3. Matrix B is of order 2 by 3. We see that both matrix has same order, but the elements on the corresponding position are not same. Here 1 1 position is 3. In this matrix 1 1 position is 5, not equal. In this position in this matrix 1 2 position is 4. In this matrix 1 2 position is 7. both are not equal, so these are comparable matrix. So for comparable matrix, elements on corresponding positions are not equal. For comparable matrix, the matrix has same order, not the elements equal. Upper triangular matrix. In upper triangular matrix, all non-diagonal elements below principal diagonal are 0, then the matrix is upper triangular matrix. Lower triangular matrix, all non-diagonal elements above principal diagonal element is lower triangular matrix. Construct a 2 by 2 matrix whose elements are given by aij is equal to I minus 2j whole square upon 3. First we write a 2 by 2 matrix. So let A is equal to 2 by 2 matrix A11, A12, A21, A22. This is a 2 by 2 matrix. Elements are given by aij is equal to I minus 2j whole square upon 3. गिवन है। अब A11, फर्स्ट वी फाइंड A11। हम इसको aij से कंपेयर करें तो I becomes 1, j becomes 1, so we put I is equal to 1 and j is equal to 1 in right hand side of aij. I1 j1 रख देते हैं. This is equal to 1 by 3. A12, इसको हम aij से कंपेयर करते हैं तो I becomes 1, j becomes 2. So put value of I and j, तो I1 j2 whole square upon 3. This is equal to 9 by 3 is equal to 3. A21, I is equal to 2 and j is equal to 1. रख दो इसमें I2 j1 whole square upon 3, 0. A22, I2 j2, I2 j2 4 upon 3. Hence matrix A is equal to A11 1 by 3, 1 2 3 2 1 0 2 2 4 upon 3. This is required 2 by 2 matrix. Question number 2. If matrix A minus B, 2A plus C, 2A minus B, 3C plus D is equal to minus 1, 5, 0, 13, then find value of A, B, C and D. Both matrices are equal, so by equality of two matrices, the elements on corresponding positions are equal, so A minus B is equal to minus 1. This is the first equation. 2A plus C is equal to 5. Second equation, 2A minus B is equal to 0. Third equation, 3C plus D is equal to 13. Fourth equation. Solve first and third by elimination method. Subtract equation first and third. Subtract equation third from first. A minus B is equal to minus 1. 2A minus B is equal to 0. B cancel. Minus A is equal to minus 1. So this implies that A is equal to 1. Put A is equal to 1 in equation third. A की वैल्यू 1 रखते हैं थर्ड में, तो 2 into 1 minus B is equal to 0. तो 2 minus b is equal to 0, तो b is equal to 2. Now put a is equal to 1 in equation second. तो a की वैल्यू 1 रखते हैं. 2 into 1 plus c is equal to 5. तो c is equal to 5 minus 2, 3. Now put c is equal to 3 in equation 4. 3 3 is 9 plus d is equal to 13. D is equal to 13 minus 9, 4.